Have you noticed just unbearably, this is something that I think people need to understand. Yes, there's a performance hit, but how bad is the hit from your experience?
So I'm going to answer that with an it depends, right? Because that's always the answer when you have a performance question is it depends, right? You can't answer performance questions without actually getting pretty specific on them, right? So when I look at but we'll do that anyway, right? Well, let's make some wild generalizations here. You know, when I think about performance and the CLR, a few things come to mind, and this may be a little disorganized, but we'll see how it goes. The first is, what's the startup cost, right? And that is actually, to my mind, the most serious problem that I have in my line of work, right? Because I'm working on these tools where, you know, we've already shipped VSTO 1.0, which lets you write little managed applications using Word and Excel. And we're working on, you know, enhancements to that right now. Since Word and Excel aren't written in managed code, that means that when the managed customization starts up, it takes some time to get the runtime loaded into memory and running and going. And that's still, even on a fairly fast machine, that's a noticeable pause. Right? And noticeable pauses give me pause, right? They bother me from a performance perspective. So that's one problem. And, you know, we have a whole team of performance people over on over in the CLR world who are, you know, thinking very seriously about that problem. Another thing that I think about is runtime performance. Right? And there you start to wonder about, okay, well, what is the cost of allocating a hunk of memory? What is the cost of doing a garbage collection? What is the cost of doing a virtual function call? What is the cost of this and that and the other thing? Over and above the equivalent cost in tightly written C++ code. Now, I don't want to make the argument Moore's Law will save us, because that's a bad argument to make. You know, and you will hear that occasionally. People will say, well, it doesn't matter if it's twice as slow, because 18 months from now, computers will be twice as fast. Right? I don't like to make that argument. The argument that I do like to make is the key to writing high-performance code is to find the slowest thing. Right? It's actually quite rare that the performance of a piece of code is degraded because all of it gets a little bit slower. Right? Typically, it's the 80-20 rule. You know, you spend 80% of the time of the program in 20% of the code. And if you can find those hotspots and optimize the heck out of them, then you're going to most likely have a high-performance, very performant program. So I am not that concerned about the performance hit of the added abstraction that the CLR affords, because I know that because the profiling tools and whatnot are, you know, improving, that I will be able to find the algorithmic hotspots in my code and make them, you know, and tune them.